Jason Casey with BeamIo. Thanks so much to Xerion for the opportunity to talk here. So today I'm going to be talking about combining form data with the latest advances in geospatial and remote sensing technologies. So as most of you here know, Xerion's form technologies have enabled users to quickly and effectively collect large amounts of data, far more than possible using traditional means. So this is great and wonderful for organizations who need to collect a lot of data quickly. It can also start to bring about new challenges. If organizations need to process more data and make sense of it all, it can quickly become difficult, especially if you are trying to do advanced things like geospatial analysis. So now imagine a bigger problem. Imagine you want to start using imagery to supplement the data that you're collecting. There are new commercial satellite companies like Planet that are collecting imagery of the entire Earth every single day. Not only that, but each data point is at 3-meter resolution. So this brings about some amazing and exciting potential capabilities. There's a lot that we can do with this, but it brings about another entirely new set of challenges. We already know that it's hard to do geospatial things effectively with the data that we already collect with forms. It's hard to do things with imagery in general. And if we want to combine it all together, it's a very complex challenge. Not only that, but there's a lot of shortcomings with existing solutions. If you want to use remotely sensed data, such as imagery from satellites or drones effectively, there's a lot going on here. There's a lot of physics that needs to be involved. If you don't have at least one remote sensing expert on your team, you're probably not going to be able to do anything incredibly useful with imagery. If you do have an expert team, then you run into a new set of challenges. A lot of tools out there aren't very great for solving end-to-end problems. The software tools for geospatial analysis, for image processing, and for software architecture in general are all very different. So if you do come up with a good solution, you're probably going to end up integrating these software tools together in kind of a clumsy way, and it's probably going to be a slow and expensive process. Lastly, if you do get your solution in place and it works well for you, it'll probably work pretty well on a desktop computer, but if you want to scale to take advantage of the new amounts of image data that are coming online, it's just not going to scale very well. So we think we've come up with a pretty good solution to these problems, and we think that it should be easier for organizations to be able to combine geospatial data and imagery and other types of data in a way that's much easier than it is now. So that's what we're going to show you now. Our solution is our product called TileDriver. And TileDriver handles data from a wide variety of different sources, spreadsheets, form data, databases, just to name a few. It has data management capabilities built in, so it can actually act as a central repository to manage all of your geospatial data. It has integrations with popular geospatial tools that are already on the market. We have partnerships with Planet, so users can start taking advantage of large-scale imagery collected every day. It's also been built to be data source agnostic, so we're not just talking about satellite imagery. We can pull in imagery from airborne platforms and drones as well. What else? So it's cloud-enabled. There's no software to download, and the only requirement for the user is a web browser, and it works on mobile as well. So that's it for slides. I'm going to move on to some demos here. So we're looking at a map here. This data was collected by Xerion's friends at the Washington State Department of Agriculture. And what we're looking at is moth trap locations. Moth traps were set out in the field, and when they were placed, their locations and times were recorded. And now we can see on the map, there's a lot of data here. It's pretty dense. There's a legend over here that color codes these points based on their timestamps. But it's really tough to get a good sense overall of what's actually going on the ground. It's a little bit tedious to look at legend and try to match it up to the map. And also the points are very dense. There's over 25,000 data points here. So viewing this in a way that is meaningful can be pretty tough. It can be pretty challenging to visualize data in a way that helps draw insights and drive decision making. So what we're going to show you is same data, this time in our platform, TileDriver. Now, instead of viewing points, what we're looking at here is clusters of points. Zoom in and out, and we can mouse over these locations. So we actually have numbers. We actually know the densities of points here. So we have very few points over here. We have a lot of points over towards Seattle. And we can also tell the geospatial extents that they cover. As we zoom in, we get more and more granular details about what's going on. So we can draw more insights as we zoom in and take a look at what's happening on smaller spatial scales. Until finally, we can get down to the single trap level, and we can pull up metadata associated with all of these traps. So this is one example of a better way to visualize data beyond just looking at points on a map. Now we can take it to another. I'm going to show another demo or another example of how we can visualize this in a more powerful way. So now we still see the densities, but we also see this hex cell aggregation. And what's going on now is we're grabbing all of our data and we are color coding it. And here we're color coding based on time. The dark red indicates that the traps have been out longer, and lighter shades such as white and lighter shades of red mean the traps haven't been out as long. So we get a snapshot of what's going on. Over here we have a small number of traps and they've been out longer. And over here we have more traps and they probably haven't been out as long. So we can tell right away that we get more bang for our buck if we want to spend more coordination efforts in these dense areas. Now as we zoom in, we can also see the same type of thing that we saw before with the densities breaking out. But these hex cells stay the same size. And that's because we've set this up so the hex cells are at 10-kilometer resolution. Each point spans about 10 kilometers. But we can quickly change this on the fly. So instead of looking at a geospatial extent in meters, we can now aggregate these points so that the clusters get tighter and tighter as we zoom in. And this is powerful because it means that we can do very large-scale planning, something like on a statewide level. And we can also do more detailed and planning on smaller scales. And all we have to do is zoom in. We don't have to do any more work. So zooming in here, we can see on a smaller scale, there's older traps in this location. And this is all done dynamically and on the fly. There's other capabilities built in here that are pretty useful. If the color schemes kind of clash between the clustered points and the hex cells, we can quickly customize this. Pulling up a new color palette. And now we get the hex cells that just change color dynamically on the fly. So we think that these are some pretty great capabilities, much better than just looking at points on a map. And this is just geospatial data that we're looking at right now. There's a lot of data that we're processing. There's 25,000 points, as I said, and we can adjust and kind of do things dynamically on the fly. But all that we're working with here is locations and the timestamps. So you don't need a lot of metadata associated with the data that you collect to make these tools useful. And it doesn't complicate your form collection process, and you don't really need to do too much more work. Now let's take a look at some imagery. I'm going to zoom out here. So we have a base map that we see here. This is just a vector-based map, but we can also pull in satellite-based map. So we've probably all seen satellite base maps, and it gives you some additional context. You can see what's going on, where the points are, if they're close to roads, if they're close to cities, if they're close to mountain ranges, et cetera. But it provides kind of limited value if you want to get into more advanced functionality, such as finding out what's happening or how things are changing over time. Now, a lot of platforms out there will let you pull in additional imagery and other base maps, and we can as well. This is the NAPE data set collected by US Department of Agriculture. And this imagery has some enhanced capabilities. You can do things with this imagery like create vegetation health maps. There's actually a lot of imagery that we've processed here. All in all, to show this example, we've processed over 120 gigapixels of imagery. And what we're looking at now, we're actually managing over 1 million image tiles that we're streaming here to the web browser. So this is an image for 2013. And this is an image for 2015. You can switch back and forth between these base layers and try to get some sense of how things are changing. And a lot of other platforms let you do this, but it's still of limited use. There's shading changes that can trick your eye. We're not doing any actual real image processing. A lot of this is still dependent on human interpretation. So what we did is we used TileDriver to create vegetation health maps of both images, and we took the difference. Now what you're looking at is the difference in vegetation health from 2013 to 2015. The shades of purple indicate that vegetation has become more healthy from 2013 to 2015. Really dark shades might indicate that new vegetation grew where there was no vegetation before. The orange, shades of orange indicate that vegetation became less healthy, or if they're very dark orange, might mean that a patch of land was paved over, a development went up, or there was logging activity or deforestation. So now what we can do, we can zoom around on this map, and we can see, oh, here's some regions where there's some logging activity. And if we want to see how, as the environment changes over time, how this affects things like moth populations, now we can better coordinate where to focus our efforts on where to put out moth traps. So we also have Esri integrations. So the same types of so those same images that were processed in TileDriver, we're not trying to be a drop-in replacement. You can use TileDriver to do these types of advanced analysis and processes, and then data up into Arc. I'm sorry, I can't figure out how to pull it up right now, but we do have integration, so you can pull those maps into Arc if you need to. Let's see. So pretty much it. This is just one demo that we've put together for this summit. There's a lot of capabilities that we haven't shown you. For things like disaster relief, we have processes where we can automatically go in and do other types of change detection. During the Haiti earthquake in 2010, the Red Cross handed out blue tarps, and the process was we need to find where all of these displaced people are going with tarps, and it's a lot of human analysis involved. And some of the tools that we've developed help alleviate a lot of the human in the loop and very labor-intensive processes, so we can automatically go in, find blue tarps, find where aid needs to be delivered, and things like that. And we have other demos that we can show you. We're set up right outside here. So we'd like to thank our friends at Xerion for this opportunity to talk. They have a great product, and we'd like to hear from some of you about how you're using it. And we're excited to see how our technologies together can help some of Xerion's users. So if your organization wants to take your data to the next level using geospatial technologies, come talk to us. Hope you enjoyed our talk. Thanks a lot.